Okay, good morning for me. Let's look at 812 and 813, lethal dose 50 and response curves. So this gets into testing different drugs, different chemicals, and seeing when they're harmful to species, animals, us, etc. And the dose makes the poison. So an important thing to remember, I think we've heard apple seeds have cyanide in them, which can be poison. It's a very, very tiny amount, so that's not going to poison you, but a large dose of cyanide would. So keep kind of that in mind. So lethal dose um, is referring to a dose that is lethal enough to kill 50% of the population tested. So for example, we've got a sample of fish here, and we start increasing the exposure to some kind of chemical or some kind of drug, and we see that the population starts to die off. And when we hit 50% of the population, then we know what the lethal dose amount is that kills half that test population. Okay, so LD stands for lethal dose. LD50 is the amount of the material given all at once, not a little at a time, which causes the death of half the population being tested. This is a very big thing here. It is not half the population of the species. It is half of the test population, like 20 rats or something like that. It's not the whole population of rats in the whole world. And a lot of times students say that in their FRQ and they get it wrong. Okay, so remember that definition, super important. There is an LD50 for almost everything, even water. So if you had 6 liters of water all at once, it would kill half the population of people. What? That's crazy. I don't think you can have 6 liters of water all at once because your stomach couldn't hold all that. So you can see this many coffees, these many alcohol shots, etc., etc. So everything has an LD50. All right, LC stands for lethal concentration. And we talk about that when it's a chemical, and usually we talk about that chemical being in the air. So the lethal concentration of a NOx or of a SOx or of a VOC, something to that effect, or maybe even ozone. So for our air pollution, that would be important. Stuff coming out of a tailpipe of a car would have an LC value. So usually we do that in environmental studies for the air. Sometimes if it's being polluted into the water, then we'll have an LC for some kind of chemical being dumped into a waterway too. So know the difference between LD and LC. All right. I guess one side note on this, the lethal concentration, that's why a lot of times we hear about dispersants. So we don't have a concentration of the chemical, so it's not lethal. It's dispersed into a lesser concentration. Okay, a dose response curve is something done when you're studying how effective a drug is. So let's just take even the vaccine for COVID recently. This is the testing that has to be done before it's released and say it's okay for people to take. So you look at different concentrations or different formulations of medicines, and you put it into your test population, and you look at the curve. And as soon as the curve starts going up off of this concentration, it's effective. So at this concentration, it's not effective. It's not effective. It's not effective. Drug A starts to become effective at this concentration. Drug B isn't effective until this concentration. And drug C is not effective until this concentration, which means this is more micrograms usually of the drug. So more drug, more effective for these ones. Less of drug A makes it effective immediately. So you have to buy less of it. That's kind of a good thing. Okay. And then you see this sharp spike. So it's being effective, and then when it levels out, That's its maximum response it's going to get. That's as good as that drug is going to become. So you can make some conclusions off this curve. Drug A has a greater biological activity at a smaller concentration, but it also has an efficacy that's the same as drug C. They both flatten out at the same spot, but you have to use way more concentration of drug C than drug A. So if you're a pharmaceutical company, you probably want drug C because people have to buy more of your product to make it work. Whereas drug A, you don't need as much, or you charge more for A compared to C or something to that effect. Drug B, you use kind of a moderate amount of the drug, but it's only half as efficable or half as effective. So you're not going to get as good a response for drug B as A or C. So if that's confusing, read this. Maybe it'll make more sense, but that's the general gist of how to read these curves. You do not have to make these curves. You used to, but you don't now. You just have to understand them and be able to interpret them and talk about them on the test. So remember, a lethal dose or a lethal concentration are values of the substance that will kill. Dose response is the amount of drug that yields a response from the body to the drug. So you're sick, you need medicine, and the dose response is how much you need to have the medicine make you better. Pretty simple. Okay, here's a video about log graphs. You used to have to make them, now you just have to understand them. So the big thing here is when this curve goes up, you find out where the 50% line is, and then you come straight down, and that tells you your effective concentration or your effective amount that is 50% response. So this works with LD and LC, and sometimes the dose response, to see if a drug's effective, they call it the EC, the effective concentration. So those are kinds of some things you need to know. All right, this is from an FRQ. So they will only plot the data points on the table. So this is a log graph. Notice it goes by tens. So this is thousands. Is that right? No, 10,000s, thousands, hundreds, tenths, ones, and tens. And sometimes they do this graph just because it's a wide range of data and it's easier to see a relationship. So this is copper sulfate concentration. It's a LD50 test to see how toxic copper sulfate is. Number of dead brine shrimp. So sometimes it's rats, sometimes it's mice. This time it's shrimp. And so we can see what's going on. So this concentration, nothing happens, nothing happens, nothing happens. As soon as this curve starts to go up, we have a threshold level. So the threshold is when species begins to die. Or become affected. So as soon as that curve stops being flat, whoop, that's your threshold level. So that's good to know. Okay, so then it starts going up, 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 and then it flattens out. So remember, a lot of times we need to know what the LD50 is. So here's 40, here's 60, so this is 50. This is testing to see if you know how to read a graph. So you follow this 50 all the way over, and right where it hits the curve, you would come down, and that would be the LD50 amount of copper sulfate that would kill half of this brine shrimp population. Another thing to know is this is never a line. This is always a curve. It's an LD50 curve. So if you did a straight best fit line, that would be wrong. And so keep that in mind when you're looking for curves that should be correct or not. And then, where's my pointer? Let's see. Always remember it needs a title on the top and the X and Y axes as well. That's pretty much it. It's not super hard once you practice it a couple times, which we'll do in class. It's pretty straightforward. Okay, hope that helps. See you soon in the class.